P3 is on 19th of May. Okay, these are the dates for your Cambridge exams. P1 2nd, M1 7th, S1 14th, and P3 19th. All right. To start the recording. So this is working. Okay, we're just starting in a minute. I'm sorry, I'm just setting one thing up, and then we begin. Okay, so let's get started with geometric distribution. This is the next topic that we're doing. This is the next concept that we're doing. It's the same topic, discrete random variables, but this is one last major concept that we had left in this topic, and that's what we will be doing. What happened to this? Okay. Is my screen still visible to you guys? Is my screen visible to you guys? Yes, it is. Okay, so maybe there's some problem with on my end. Let me double click on this maybe. Okay, no, it's fine. Okay, good. So this is the next concept that we have in this topic, geometric distribution. We will be covering the concepts of this today and also do some past paper questions to understand how this is going to work. We've talked about binomial distribution before. Now, let me give you a quick reminder about that. Remember, in binomial distribution, what we had was something was repeating, something was happening again and again repeatedly, right? So you had something repeating n times, a fixed number of times. There were two possible outcomes, success or failure, and their probabilities remained constant. And what we were looking for was probability of getting a certain number of successes, right? Probability of getting 4 successes out of 10, probability of getting 10 successes out of 25. So we were looking for probability of getting a certain number of successes in binomial distribution. That's what we were looking for in binomial. Now, what is geometric? Let's try to understand that using this example. I'm sure some of you must be cricket fans, and you might not be anymore after the last year or two, what's been happening to the Pakistan team. But considering our current situation, as far as cricket is concerned, let's say if the Pakistan team plays any match randomly with any team, Scotland, America, Ireland, Bangladesh, any team, let's say, the probability of them winning is, let's say, 0.2. Okay. And then if the probability of winning is 0.2, what about the probability of losing? That would be 0.8, right? Now, what if we wanted to find the probability that so Pakistan team is playing matches repeatedly, one after the other. So after every 2-3 days, they have another match, right? So they are playing matches like this for the next year or year and a half like this. We want to find the probability that the first Pakistan win comes in their fourth match. So starting from now, the first win comes in their fourth match. What would be the probability for that? Now, the keyword here is that the first win comes in their fourth match. Okay, probability that the first one comes in their fourth match. Now, what does that mean? If fourth match is the first one that they win, what about the first 3 matches? It means that they lost those matches, that they lose those matches, first, second, and third match, right? What would be this probability then? How do you calculate that? You say, if the fourth match is the first one that they win, they lose the first match, they lose the second match, and then they lose the third match, and then they finally win the fourth match. What would be the probability for that? Probability of losing the first match, that's 0.8. Probability of losing the second match, 0.8. Probability of losing the third match, 0.8. And then finally, probability of winning the fourth match, that's 0.2. Okay. And now what we can do is we can find out this probability and see what that turns out to be. That's 0.8. You can simplify this like this as well. You can say this is 0.8 raised to power 3 times 0.2. And that simplifies to 0.8 raised to power 3 times 0.2. And that turns out to be 0.1024. That is the probability that the first Pakistan win comes in their fourth match. Okay? That's 0.1024, and that's how you can calculate this. Okay. Now, this particular situation is basically something that can be classified as a geometric distribution. This can be called a geometric distribution. Why is that? What exactly is a geometric distribution? In a geometric distribution, we basically look for the probability of getting our first success on a particular attempt. Okay, remember, in binomial distribution, we were looking for probability of having a certain number of successes. Okay. In binomial, we were looking for the probability of having a certain number of successes out of some number. In geometric, it does not matter how many matches we win, as in we're not looking for probability of getting a certain number of successes. We just want to see the probability of getting our first win in a particular match. Okay, so the probability that the first one comes in the fourth match is going to be this 0.8 raised to power 3 into 0.2. The total number of matches here is not relevant, right? In binomial, we wanted the total number of matches as well, right? But if we had 10 matches, we wanted to see, okay, out of 10, what's the probability of getting 4 successes, 4 wins? Now, in this case, we don't care about the total number. The total number could be infinite, doesn't matter. We just care about the first win, okay? Now, this is actually geometric distribution. We'll talk about the conditions of geometric distribution in a moment. But this is what the formula looks like for a geometric distribution. Probability of x equal r, that is given by q raised to power r minus 1 times p. That's the formula for a geometric distribution. Now, these letters mean the same thing as before, just like binomial distribution. P means probability of success. This is probability of success. Q means probability of failure. There's no n in this case. Notice in the formula, there's no n. We don't need to know how many times we are repeating something. We're just doing something over and over again, but the total number is not fixed. Okay. Now, what about x? What does x represent here? X is the number of trials or the number of attempts or trials needed until the first success. This is another keyword that you will see being used in the questions a lot. Until something happens. Until first success. These are the keywords that you will notice in geometric distribution questions. You're looking for the probability of getting a probability of having a certain number of attempts for the first success. Okay. Now, x is the variable, right? It can take different values. So you might have your first success in the first attempt, the second attempt, the third attempt, the fourth attempt, and so on. So x can take different values, right? X could be 0, 1. No, it can't be 0. X could be 1, 2, 3, 4, all the way up to infinity. There's no limit to it. What about r then? R is the value of x. The value of x you want the probability for. The value of x that you want the probability for. Now, I'll explain what that means in a moment. X is a variable that can take any of these values, 1 to infinity, right? Any integer, any positive integer. It can't be 0, of course, because you can't get your first success on 0th attempt, right? That's a lesson as well. If you don't attempt at all, if you don't try, you don't get that success, right? You have to attempt something. You have to try something to get your first success. So x cannot be 0, right? X starts from 1. In binomial, x used to represent number of successes. Now, the number of successes could be 0 as well. So in binomial distribution case, we also considered 0 as a possible value for x, right? In this case, x could be anywhere from 0 to n. But in geometric distribution, it starts from 1. Okay, it does not start from 0. So now that we have this formula, we could actually use this formula to find that same probability as well. If we want to find the probability that the first Pakistan win comes in their fourth match, what we're actually looking for is probability of x equal to 4. Probability that the first success comes in the fourth match. Now we just input values in this, q raised to power r minus 1 times p. In that case, winning is what we're calling success, right? So p is equal to 0.2, q is equal to 0.8. So if we use this formula, what do we get from this? Q raised to power r minus 1, that means 0.8 raised to power 4 minus 1 times p, which is 0.2, and that will give you the result, which is 0.1024. So we got the same probability logically earlier, but now that you realize that it's actually a geometric distribution, we'll talk about conditions in a moment. If it is a geometric distribution, you could just remember that this is the formula that you have to apply there. You don't have to think about anything, just apply the formula, input values in that, and you get the result. But now the question is, how do we know it's a geometric distribution? How do we know that we can use this formula? How do you figure that out, right? That's the question now. Now for that, we have some conditions, just like we had some conditions for binomial distribution. We have some conditions for geometric distribution as well. Remember the conditions for binomial distribution? We needed repeated trials. So I'll just copy this there first of all, and then notice the changes that I do here because they are going to be important. You need to be able to differentiate between a geometric distribution and a binomial distribution. So for now, these are conditions for a geometric distribution. Okay, now I'm going to edit them a bit. In binomial distribution, you had repeated trials. You had something happening repeatedly. Okay. But in that case, n had to be something that is fixed, right? So if you're repeating something 10 times, you say the value of n is 10. If you're repeating something 15 times, you say the value of n is 15. So n had to be fixed in the case of binomial. Now here as well, you have something happening repeatedly. You need something happening again and again. Just like here, you're playing, the team is playing matches again and again, one after the other, something is repeating. But the total number does not have to be fixed, right? We don't necessarily need to know the total number because that's not used in our calculation. Q raised to power r minus 1 times p, there's no mention of n there. The total number is not going to be fixed here. N is not fixed. It's not finite. It just continues forever. So we can say this represents the number of trials, right? This is not fixed. In binomial, it used to be fixed. That's one major difference between binomial and geometric. The other conditions are the same. Here as well, you need two possible outcomes, success and failure. Their probabilities should remain constant. They should not be changing here as well. Okay, so that's also the same. And the outcomes should be discrete. That's kind of obvious. These are discrete outcomes, 1, 2, 3, 4, 5, and so on. So yes, they are discrete as well. So the other conditions are the same. So as far as the conditions are concerned, the only difference is in binomial, n was fixed. In geometric, it's not necessarily fixed. Okay, now that's one thing that you can differentiate it from. But the major difference that you should actually look for to identify if it's a binomial distribution or a geometric distribution is in binomial distribution, you used to find the probability of getting a certain number of successes. Now here, you are finding the probability of getting your first success at a particular attempt. So you're talking about first success here. In binomial, you're talking about number of successes. So here, the variable x represents the number of attempts, or you can also call this number of trials or the number of repetitions needed until you get your first success. Until first success. That's what x represents in a geometric distribution. So in binomial, you were talking about number of successes. This is important. In binomial, you're talking about number of successes. In geometric, you're talking about first success. Number of trials needed until first success. Number of attempts until first success. That's the key difference. That's the main difference between these two distributions. Binomial is for number of successes. This is for number of attempts until first success. Okay. Once you have something that satisfies these conditions and you're looking for the probability of getting your first success in a particular outcome, you know that that's a geometric distribution. Okay. Now let's do some examples of this. So we've got that same scenario. We've got the probability of winning 0.2, probability of losing any particular match, that's 0.8. We need to find the probability that the first Pakistan win comes in their 6th match. Okay, we've done this before. So probability of getting their first win in their 6th match, what's the formula? The formula for a geometric distribution looks like this. It's q raised to power r minus 1 times p. Okay, let's input values in that. We want the first success in the 6th attempt. So x equals 6. We want to find the probability for this. Just input values in that. Q is equal to 0.8. P is equal to 0.2. Let me write that down here. Just input values in this. 0.8 raised to power r minus 1. What does that mean? 6 minus 1 times p, which is 0.2, and that should give you the result. You can see what that is. What's the result that you get from this? Anyone? What do we get from this? Point 0.065536. Okay. 0.065536. This is an exact number. This is not something that is non-exact. Non-exact is when you have decimal places continuing forever, they're not ending. This is an exact number. You can leave it like this as well. You don't necessarily have to round it off to three significant figures. You can leave it as your final answer as well, as it is 0.065536. Okay. All right, let's have a look at the next example. Now, this is important. This is extremely important because the next examples are all going to depend on this now. Find the probability that the first Pakistan win comes after their seventh match. After their seventh match. What does that mean now? The first win comes after the seventh match. How do you think about this? What was the formula? The formula for a geometric distribution is probability of x equals r, that is equal to q raised to power r minus 1 times p. We know that the probability of success in this case is 0.2, probability of failure is 0.8. And what we're looking for is probability that the first success comes after their seventh match. So what are we looking for? We're looking for probability of x greater than 7, right? Now in binomial, what we used to do was, we used to calculate each of those probabilities one by one, right? So it's greater than 7. Greater than 7 means it could be 8, 9, 10, 11, 12, 13, 14, 15, and so on, right? It could be all of them. In binomial, we had a finite number. So for example, when we did probability of x less than 2, for instance, we said, okay, less than 2 are two possibilities, 0 or 1. We find their probabilities and then add them up together. Then we had x less than or equal to 6. We could either add 0, 1, 2, 3, 4, 5, 6, or in this case, the total number was 9. So we said, okay, just subtract from 1 these 3 cases. So we had a finite number. We could calculate those probabilities like this. Now, here what we have is probability of x greater than 7. X greater than 7. How do you find this now? There's no end to it, right? The total number is not fixed. So one idea is that you say, okay, x equals 8, x equals 9, x equals 10, but where do you stop? Where do you stop now? It just continues like this. There's no end to it, right? It continues forever like this. You can't find all of those probabilities. So what do we do then? One idea could be that you say 1 minus x less than or equal to 7. So you find the probability for x being equal to 1, 2, 3, 4, 5, 6, 7. Subtract all of them from 1 and you would get the result. That's one idea. That would work, although that still requires you to do like 7 calculations. That's a lot of work, right? Could we do it more efficiently somehow? Could we do it more efficiently? That's the question. Okay, this could be one idea. You can try this. So I'll just leave it here for you. This could be one way of doing this. That you say, okay, 1 minus probability of x equals 1, x equals 2, x equals 3. x equals 4, x equals 5, x equals 6, and x equals 7. You subtract all of these probabilities. Okay. From 1, and you would get the result. That's one idea. But we can do it more efficiently. Now let's understand how exactly we can do that. So first of all, greater than 7. After the 7th match, it does not mean, after the 7th match does not mean 8th match. It could be 8, 9, 10, 11, and so on. It could be any of them. Okay, it's not necessarily 8. It could be any match after the 7th match. Now, if the first win comes after the 7th match, now hear me out very carefully. If the first win comes after the 7th match, what does that tell you about the first 7 matches? If the first time that the team wins is after the 7th match, that means you lost the first match, you lost the second match, you lost the third match, all the way up to the 7th match, you lost all of them. Let me write that down here. So this was one idea. A better way of doing this, a more efficient way of doing this, is you say you're looking for the probability that the first win comes after the 7th match. You're looking for this probability. That's the same thing as saying that the first 7 matches are all losses, right? If the first time you are winning is after the 7th match, then the first 7 have to be all losses, right? You should have lost all the first 7 matches. So probability of x greater than 7 is actually the same as you losing the first 7 matches. What would that be? You lose the first match, you lose the second, lose the third, lose the fourth. That's basically the probability of losing the first match was 0.8. You lose the first 7 matches, that's 0.8 raised to power 7. And that should give you the result directly. 0.8 raised to power 7. This is 0.209. That's the value for this probability. Probability that the first win comes after the 7th match. That's equivalent to saying that the first 7 matches are all losses, and that's given directly by 0.8 raised to power 7. So if you were to try this, calculate this whole thing, you would see that's the same as 0.209. So you could do it directly like this. So that's the logic behind it. And now what you can do is you can remember a formula that you can use directly in problems like this. And what's that formula? Using this, you can arrive at this formula. You can say probability that x is greater than r. This is equal to q raised to power r. That's exactly what we've done here. In place of 7, we have r here, right? If we want to generalize this. So in place of 7, we've got r here. And this was q, 0.8 was q. So that gives us a formula that we can use directly for problems like these. Probability of x greater than r in a geometric distribution is given by q raised to power r. And now what you would do would be you would memorize this formula. This is not given in the formula sheet. You can use it directly if you memorize this. Probability of x greater than r is equal to q raised to power r. So x greater than 7, this probability is just 0.8 raised to power 7. You can do it directly like this. Any question on this? Any problems with this? Is this formula clear to everyone? Is the logic clear? So first win coming after the 7th match, that's the same thing as saying that the first 7 matches are all losses. So that's what we're using here. We're saying, let's look at it a different way, right? Instead of saying the first win comes after the 7th match, we say the same thing in a different way. We say that the first 7 matches are all losses. That necessarily means the first one will come after the 7th match. Okay. So that's a formula that you can remember now. X greater than R, that's equal to Q raised to power R. So one formula that will be given in the formula sheet is this. Q raised to power R minus 1 times P. That's the formula that's given in the formula sheet, although in a slightly different way. In the formula sheet is going to say 1 minus P raised to power R minus 1 times P, right? Because Q is the same thing as 1 minus P, but you get that, right? That's the formula given in the formula sheet. This one is not given in the formula sheet. You need to memorize this. I would recommend that you understand it, but then you memorize the formula, okay? If you try to do it directly, it's going to be a 1-mark question, maximum 2-mark question in the exam. It's very unlikely that you would be able to figure this out in 2-3 minutes. You'll end up spending more time on this, and that's not going to be worth it. So if you memorize this formula, that will be much quicker. You can just get done with this in 1 minute, and that's it. Otherwise, if you try to make your own logic, that's going to take more time at that point. So yes, understand it, understand the logic behind it, but then memorize this formula as well. X greater than R equals Q raised to power R. So I'll just ask you to remember this one formula. There are other formulas as well, but we will make them ourselves. We will just remember this one formula, right? Every other variation of inequality. So for example, if you have greater than equal to, less than equal to, less than, we will do that. We will do them directly, okay? But this one formula we're going to remember, okay? Probability of X greater than R, that is equal to Q raised to power R. Okay. Now, let's look at the next example. What if they say the first Pakistan win, the first win comes in or after the 7th match? In or after the 7th match. Okay, how do you understand that? We're looking for the probability of X, the first win, being either in the 7th match or after the 7th match that's greater than or equal to 7. Okay, that's the probability that we're looking for. How do you find this now? What are the formulas that we have? One formula that we have is probability of X equals R, that is given by Q raised to power R minus 1 times P. And the other formula that we also know now is X greater than R, the probability for this is Q raised to power R. Whenever we have an inequality in a geometric distribution, what we will do would be, we would convert that to this form. Yes, we will convert that to this particular form. Whatever inequality it is, we will switch it around in a way so that it converts to this form and we can use this formula. Okay, now how do we do that? Greater than or equal to 7. What does that mean? We want 7, 8, 9, 10, 11, all the way up to infinity, all of these numbers. Can you describe these numbers in the greater than form so that you don't have an equal to sign, you just have a greater than sign? You can also say this can be described as greater than 6, right? Since these are discrete numbers, decimals are not possible. Greater than or equal to 7 is the same thing as saying greater than 6, and that will give you the result. So you say probability of X greater than 6. What's that going to be? It's Q raised to power 6. What's Q? Q is 0.8. 0.8 raised to power 6. You can see what that turns out to be. That will give you the result. That's 0.262. That's the probability that we were looking for. Make sense? Yes, Ibrahim, that would also work. So another suggestion is, Ibrahim was saying that we write it as x equal to 7 or x greater than 7. You break it like this. On this, you apply this formula. And on this, you apply the other formula. That will also work. You get the same result as at the end. That's also possible. That will also work. Okay. All right. That's good. That will also work. Okay. So that's what you do here. Let's take another example. What if the first win comes in or before the fifth match? In or before the fifth match? How do you think about this now? The first win comes in or before the fifth match. So we can write this as x less than or equal to 5. And then the next example is before the fifth match, so x less than 5. Now remember the inequality formula that we know about? That's x greater than or equals q raised to power r. Now here the problem is we have a greater than formula and these are less than. How do we convert them to that form? So I'll give you a few seconds or a minute to think about this. I'm getting a call again and again. I'll just respond to that quickly. Take a minute, think about this, and let me know what you think about both of them. How do you convert them to that required form that you got? Yes. So how do we think about this now? X greater than or equal to 5. How do we convert this to that standard form? That's the question. Less than or equal to 5. Now, since this inequality is in the other direction, we have a formula for greater than, and this is less than or equal to. What we have to do is, we have to do 1 minus something, right? 1 minus something. Let's write them down. So we have, what are the possible numbers? Less than or equal to 5. It's often easy. It becomes easier if you write them down like this: 1, 2, 3, 4, 5. These are the numbers that we want. And what are the numbers that we don't want? 6, 7, 8, all the way here. These are the numbers that we don't want. Okay. Now the total probability of anything is 1, right? The total is 1. We want the probability for these numbers. So what we do is we say, let's subtract from 1 all of these numbers. Subtract from 1 probabilities of the numbers 6, 7, 8, 9, 10, 11, 12, and so on. How do you describe these numbers in greater than form? How do you describe these numbers in greater than form? These are greater than 5. So probability of x less than or equal to 5 is the same as 1 minus probability of x greater than 5. What does that become? That becomes 1 minus q raised to power 5, and that's 1 minus 0.8 raised to power 5, and that should give you the result. You can see what that is. 1 minus 0.8 raised to power 5, that is 0.672. That's the final answer that we've got. 5C4, where does that come from? It's not binomial. This is geometric. We don't have combinations here. Is that okay? Any questions on this? Yes, Nabila?
Assalamu alaikum, sir.
Alaikum assalam.
So, sir, if we consider x is less than equal to 5, that means that one win is coming between 1 and 5. So we can think about it
No,
like
no,
this,
no,
that
no, no, no. Okay. So not one win. coming, and it's not that the first one win comes before between 1 and 5. We're talking about the first win. The first win comes in the first 5 matches. So it could either be the first match. Whenever the first win comes, you stop there. You don't go on after that. Okay. So a geometric distribution basically stops when you have your first win. So if the first win comes in the second match, let's say, we're not saying then you go on and lose the third match, lose the fourth match, lose the fifth match. It's not like that. So when you get the first success, the distribution stops there. You don't go any further than that. Does that make sense?
Yes, sir, that's
Okay,
clear.
so if you still have that question, so I think that's where the problem was, right?
Yes, sir.
Okay, good. So we are only talking about the first success here. So whenever the first success comes, we stop at that point. So there are no combinations that we use here. Okay, so that is what we get for this probability. What if it's less than 5? What about this now? Less than 5 means we want 1, 2, 3, and 4. And what we don't want is 5, 6, 7, 8, all the way from this. These are the ones that we want. So we say, let's subtract from 1 all of these numbers. How do we describe these numbers in greater than form? These are all numbers that are greater than 4. So we can say it's 1 minus probability of x greater than 4. What's the probability of x greater than 4? That is q raised to power 4 using this formula. So that becomes 1 minus 0.8 raised to power 4. And that gives you the result. You can see what that is. It's 0.5904. That's the probability that we were looking for. Is that clear to everyone? So in a geometric distribution, we can deal with inequalities directly. In geometric distribution, we can deal with inequalities directly. In binomial, we could not do that. In binomial, if we had an inequality, we always had to find each number's probability separately, right? We could not use any direct formula there. But for geometric distribution, when we have an inequality, we can directly use this one formula. If we remember this, we should remember this. We can convert everything to this form and then just apply the formula. Any questions, anyone? Any problems with this? Can I get responses from everyone? No problems? Shouldn't we multiply the probabilities? Which probabilities? So 1 is the total. From 1, we are subtracting this probability. Multiplication is already happening here in the formula. So 0.8 raised to power 4, 0.8 raised to power 4 is basically 0.8 into 0.8 into 0.8 into 0.8, right? So multiplication is happening there. Okay, and C. Yeah, what about C? Why would there be any multiplication? So you already have 0.8 raised to power 6, right? So it's 0.8 into 0.8 into 0.8 6 times. So that becomes 0.8 raised to power 6. Why would there be multiplication? Oh, okay. The method that Ibrahim suggested. Okay. So he was basically saying x greater than or equal to 7. You can break it down into 2 cases. One case is that the first success comes in exactly the 7th match. And the other case is that the first success comes after the 7th match. These are 2 separate cases. It's either this or this. There's an or between them, right? It could either be the first case or the second case. So we add these we sum these probabilities. Okay. All right. Now we have direct formulas for all of these inequalities as well. I personally find it hard to memorize a lot of things like that. So my recommendation is, if you understand the logic well, just remember this one formula, and the other formulas you can make using this one formula yourself by, writing the numbers down like this. However, if you think you prefer memorizing stuff, I will give you the other formulas as well. So these are the two formulas that everyone necessarily needs to know about. Q raised to power r minus 1 times p, that's the equality formula. And then x greater than r, this is q raised to power r. These are two formulas that everyone needs to know about geometric distribution when finding probabilities. However, there are formulas for other inequalities as well, which if you want, you can memorize. So for x greater than or equal to r, this would become q raised to power r minus 1. For x less than or equal to r, it would become 1 minus q raised to power r, right? X less than or equal to 5. Yeah, that's what it becomes. And then for x less than r, it would become 1 minus q raised to power r minus 1. These are the formulas for the other inequalities. If you want to use them directly, you can do them. It's allowed. You can do that. But just don't mix them up then. Okay, don't mix them up. This is safer if you understand the logic. If you just remember this one formula, you can convert everything to that form. And that's the easiest one to remember out of these all as well, q raised to power r. And then you convert everything to this form to do that calculation. Okay, so now it's your choice, however you want to do it. I'll be doing questions by converting everything to this form. Okay. All right. Now, just like for a binomial distribution, we talked about mean of the distribution and the variance of the distribution. For a binomial distribution, the expected value or the mean was given by n times p, and variance was given by npq. For a geometric distribution, similarly, we have a direct formula for expected value or the mean of the variable. Expected value is the same thing as the mean of x. For a geometric distribution, it's given by 1 over p. Right? That's the formula for expected value of a geometric distribution. It's given in the formula sheet as well. That's what it is. There's another notation that we use for expected value as well. I told you about this before. It's also represented by mu sometimes. Mean has another notation. It's also represented by mu. So in the formula sheet, sometimes they use mu as well. Okay, it's 1 over p. Variance is not defined in case of a geometric distribution. Okay, only the mean is defined. Variance is not defined for a geometric distribution. And then parameters of a geometric distribution, just like for binomial distribution, we needed two things to define it, to describe it. One was n and the other was p. For a geometric distribution, there's only one parameter. Since there's no n, the only parameter that we have for a geometric distribution is p, and that's the probability of success. Right? That's the parameter that we have for a geometric distribution. There's only one parameter, and some notation that is used sometimes. If they write something like this, x, and then this sign tilde, and then GEO, and then in bracket, if they have written 0.3, what that means is x follows geometric distribution. X follows geometric distribution with p equal to 0.3. And that's the notation that they sometimes use for geometric distribution that you need to be familiar with. So in general, you can say you have x and then tilde. Inside the number that's written, that always represents the probability of success. So if they have something written like this, remember the number inside the bracket, that would represent probability of success. Okay, so that's the idea of geometric distribution. These are all the concepts that we have in this. Now let's have a look at some questions on geometric distribution and see how this is going to be applied in those different questions, applied to those different questions. Okay, so remember these two formulas, q raised to power r minus 1 times p, and q raised to greater than probability of x greater than r, that's q raised to power r. And also remember the conditions. These conditions have to be met. This is the key thing. In geometric distribution, we will be looking for probability of having the first success in a particular attempt. Okay, in binomial, we would be looking for probability of getting a certain number of successes. Notice that difference. Remember that difference. Okay, let's have a look at some questions now. So what I'll do is I will copy some questions from this. Let me see if I can find some here. The worksheet is already uploaded, right, for geometric distribution. Okay, let's have a look at some questions in this now, from this now. Okay, let's look at question number 2 first of all. Let's start with this. These questions are mostly going to be fairly straightforward. There won't be much difficulty as such, unless you have questions in which you have a geometric distribution inside a binomial. Remember, we did one question like that yesterday, the Sudoku question, where you had one binomial distribution, and inside that you had another binomial distribution. So that sometimes happens with geometric as well, that you have a binomial distribution, but then to find the probability of success for that, you have to use a geometric distribution. Let's have a look at this example and see how to do those kinds of questions if we have them here. Let's see. The first part says, Ramesh throws an ordinary fair six-sided die. Find the probability that he obtains a 4 for the first time. First time. What does that remind you of? First success on his 8th throw. What are we talking about? We're talking about geometric distribution. Something is repeating, right? He is throwing the dice again and again, right? Because they're talking about 8th throw. So he's throwing the dice again and again. We're talking about obtaining a 4. So we can call obtaining a 4 a success. And then failure would be not obtaining a 4. What's the probability of success? Probability that you get a 4 on any one throw. There are 6 possible outcomes. 4 is one of those outcomes. Probability of success would be 1/6. And then probability of failure, that's 5/6. We are looking for the probability of getting our first success on the 8th throw. This is the criteria for success. We want the first success on the 8th outcome. What's the formula for geometric? The formula is q raised to power r minus 1 times p. Let's input values in that. Q is 5/6. So we have 5/6 raised to power 8 minus 1, which is 7 into 1/6, which is p. And that should give you the result. You can see what that is. Can somebody please do this calculation? 0.0465. Okay, thank you. So 0.0465, that's the result that we get. Okay, part B of this now. Part B says, find the probability that it takes no more than 5 throws for Ramesh to obtain a 4. Again, we're talking about obtaining a 4. So obtaining a 4 is what we're calling a success. So the probability of failure and success, it's the same as before. No more than 5 throws. What do we understand? How do we understand that? No more than 5. Can it be 5? Yes, it can be 5. Can it be more than 5? No, it can't be 6, 7. It can be 5, 4, 3, 2. So less than or equal to 5. Yes, that's what we're looking for. Probability of x being less than or equal to 5. That's what we want to find out. Now, for inequalities, we only, let's say, remember this formula. X greater than r, this probability is q raised to power r. Okay, now how do we convert it to that form? Less than or equal to 5 is 1, 2, 3, 4, 5. What are the numbers that we don't want? 6, 7, 8, 9, all the way to infinity. The total probability is 1. We subtract from 1 all of these numbers. How do we describe these numbers in greater than form? These are greater than 5. So 1 minus probability of x greater than 5. And that's something that we know. We have a formula for that. We just use that formula. It becomes 1 minus q raised to power 5. And that's 1 minus 5 over 6 raised to power 5. And that should give us the result. What do we get from this? .598. Okay, that's the result that we get from this. Okay, let's look at part C now. It says Ramesh now repeatedly throws 2 ordinary fair 6-sided dice at the same time. Each time he adds the 2 numbers that he obtains. Okay, so now he's throwing 2 dice. For 10 randomly chosen throws of the 2 dice, find the probability that Ramesh obtains a total of less than 4 on at least 3 throws. How do we understand this? So he's throwing 2 fair dice now. How many possible outcomes is that? That's 36 possible outcomes, right? 6 times 6. So there are 36 possible outcomes every time he throws the 2 dice. Okay. What we are looking for now is, for 10 randomly chosen throws, what's the probability that he obtains a total of less than 4 on at least 3 throws? Is it a geometric distribution? Is it a geometric distribution? Are we talking about first success? Are we talking about probability of getting a first success in a particular outcome? We're not talking about that. We're talking about number of successes. At least 3 successes. We want at least 3 successes out of a total of 10. The total number is also fixed, right? That's also a hint that it's going to be binomial. We know the total number, and we're talking about having a certain number of successes. Okay. So this is binomial distribution. This is not geometric. So what do we do then? Let's find the probability first of all. We're talking about obtaining a total of less than 4. That's the criteria for success. Let's find the probability for this first of all. Obtains a total of less than 4. What's the total? He is basically adding the two numbers that he is obtaining. What's the probability that the total of those numbers is less than 4? Let's first find that probability for one throw. For one throw, what's the probability that the sum of the two numbers on the two dice that is less than 4? Let's find this probability first of all. Okay, let's list down the possible outcomes that we can have. In that case, if the sum is less than 4, you can have 1, 1, you can have 1, 2, and that's it. With 1, you can have only these two possibilities. With 2, you can have 1, and that's it. There's no other possible outcome that you can have for which the total would be less than 4. Remember, it says less than 4, it does not include 4. So these are the only three outcomes that satisfy the condition. So if we say this is the criteria for success, what's the probability of success? 3 out of 36. There are 36 possible outcomes. Out of them, 3 satisfy the condition. So it's 3 over 36, which simplifies to 1 over 12. If P is this, what about Q? Q is going to be 11 over 12. Probability of success is 1 over 12. Probability of failure is 11 over 12. What's the probability that you get at least 3 successes now? We said it's a binomial distribution, right? Because the total number is fixed and we're looking for getting a certain number of successes. Probability of getting a certain number of successes, n is equal to 10. Let's use the binomial formula. The formula looks like this: x equals r. This is ncr p raised to power r into q raised to power n minus r. Let's just input values in this. N is 10. Cr, what's r? We're looking for getting at least 3 successes. Okay, so that's the formula. What we're looking for is x greater than or equal to 3. Do we have a formula for inequalities in binomial? We don't have any formula for that. In geometric, we do have a formula. That's the formula. But in binomial, we have to calculate probabilities individually for each number. Now, greater than or equal to 3 means 3, 4, 5, 6, 7, 8, 9, 10. That's a lot of probabilities to calculate. We can reverse this. We can say, okay, greater than or equal to 3 is the same thing as saying 1 minus probability of x less than 3. Right? We reverse that. Less than 3 could be 0, it could be 1, or it could be 2. Remember, it's binomial. In binomial, you can also have 0. Right? The number of successes can be 0 as well. In geometric, you can't have 0, because in geometric, we're talking about number of attempts. Getting your first success on a certain attempt. You can't get your first success on the 0th attempt, right? That's not possible. So in geometric, we don't have 0. In binomial, we also have 0. We can just input values in the formula now. 1 minus n, which is 10, 10c0, into p, which is 1 over 12, raised to power 0, into 11 over 12, raised to power 10 minus 0, which is 10, minus 10c1, into 1 over 12, raised to power 1, into 11 over 12, raised to power 10 minus 1, which is 9, minus 10c2, into 1 over 12 raised to power 2, into 11 over 12 raised to power 10 minus 2, which is 8. And that should give you the result. You can see what that is. If somebody has done that calculation, let me know. Otherwise, we'll look at the next one. No? Okay, so you can do this calculation, right? And you get the result. That's the idea. Okay, let's move on. Let's have a look at another one now. So we'll just do 2 more questions, I think, and then we end. Okay. We'll try to end by 12:15 max, inshallah. They're all fairly straightforward. There were a couple of questions that I was thinking of. Yeah, so this one. Question number 6. Let's try this. Question number 6 from this worksheet. Let's try this one now. Okay, an ordinary fair die is thrown repeatedly until a 5 is obtained. The number of throws taken is denoted by the random variable x. Write down the mean of x. Okay. You are throwing something repeatedly until you obtain something, until you get a success, until you get your first success. What does that remind you of? This until is also a keyword for geometric. So you keep repeating something until something happens, until you get success, right? So if we define 5 as a success, this is a geometric distribution. The number of throws are denoted as x, and that's what we have in geometric distribution: number of throws, number of attempts, right? So it's a geometric distribution. What's the expected value? The mean of a geometric distribution. Mean of a geometric distribution is given by 1 over p. What's the probability of success? It's a fair die. Probability of getting a 5, what's that? That's 1 over 6. Probability of success is 1 over 6. We just input that value here in the formula, 1 over 6, and we get 6 from that. The mean of x is given by 6, and that's our final answer. Okay, that's the first part. It's really straightforward. Part B, find the probability that a 5 is first obtained after the 3rd throw, but before the 8th throw. After the 3rd, but before the 8th. After the 3rd means it could be 4th, it could be 5th, it could be 6th, or it could be 7th. So it could be anywhere from 4 to 7, right? Now, in this case, these numbers are not that many, and we can find them separately as well, and that's okay. We can say one way of doing this is, let's just find the probability of x equals 4, x equals 5, x equals 6, x equals 7. You can find each of them separately like this, add them up together, and that should work. Okay? Let's see what that turns out to be. The formula for geometric distribution, that is given by q raised to power r minus 1 times p, right? Let's apply that formula on each one of these cases one by one. If p is 1 over 6, what about q? Q is 5 over 6. So we say 5 over 6 raised to power 4 minus 1, that's 3, times 1 over 6 plus 5 over 6 raised to power 4 into 1 over 6 plus 5 over 6 raised to power 5 into 1 over 6. And then finally, 5 over 6 raised to power 6 into 1 over 6. You have to show this working. You can't write down the answer directly. Okay, this working is important if you do it this way. And that should give you the result. You can see what that is. Now, that's one way of doing this. It works. It is quite some calculation, but still, it's all right. It's doable, right? It does not take that much time. But there could be an alternative. Since it's a geometric distribution, we could make use of inequalities to make it slightly more efficient. How do you do that? So can somebody do this calculation, please let me know while I do it another way. So what we want is, we want the first success after the 3rd throw, but before the 8th throw. After the 3rd, before the 4th. So these are the 4 numbers that are possible. The 4 numbers that are possible are 4, 5, 6, and 7. These are the 4 numbers that are possible. The inequality formula that we have looks like this. Probability of x greater than r in a geometric distribution is given by q raised to power r. It is a geometric distribution. We're talking about first success. How could we use this formula to make it a bit more efficient? Any idea? Could we make it more efficient using this formula somehow? These are the numbers that we want, right? 4, 5, 6, 7. Now, around these numbers, we might have 1, 2, 3. These are the numbers that we don't want, right? Similarly, on the right side, we don't want 8, 9, 10, 11, and so on, all the way up to infinity. All of these numbers in orange are the ones that we don't want. We only want this green numbers, the highlighted numbers. How do we make an inequality in greater than form or multiple inequalities to basically get to these numbers exactly? One way to do this could be, you could say, let's find the probability for all of these numbers. From 4 onward, let's find the probability of all of these numbers. How would you describe them? In greater than form, you could say, it's all the numbers greater than 3, right? 4, 5, 6, 7, 8, 9, 10, 11, all the way up to infinity. These are all numbers that are greater than 3. And then subtract from this all of these numbers. How would you describe these numbers? 8, 10, 11, 9, 10, 8, 9, 10, 11, and so on. These are greater than 7. Subtract from this greater than 7. Right? So subtract from greater than 3. Greater than 3 would be all of these numbers. Subtract from them these numbers which are greater than 7. And that should give you the result. It's q raised to power 3 minus q raised to power 7, which is 5 over 6 raised to power 3 minus 5 over 6 raised to power 7. And that will give you the result directly. You won't have to do that much calculation. Yes, it requires a bit more thinking, but it gives you the result. You can see what that is. You're saying that's 0.29962. If you want to round it off, that would be 0.300. And that's the same result that you would get from this as well. Okay. Why would you add 1 to that? You won't do plus 1. So what we're doing is greater than 3 is all of these numbers, right? These are numbers that are greater than 3. Let me try to color code them some way. How can I do that? Let's take them up there. So basically, what I'm doing is I'm saying, let's find the probability for all of these numbers. How do you describe these numbers? These are all numbers that are greater than 3. Subtract from this these numbers, the probability of these numbers that is greater than 7. What would we be left with when we do this? The numbers that we need, 4, 5, 6, 7. That's what we will be left with. Okay. That's the result that we have. That could be another way of doing this. All right. Let's look at part C of this. Now it says find the probability that a 5 is first obtained in fewer than 10 throws. Fewer than 10 throws. How do you understand that? Fewer than 10 throws, that's x less than 10. Now that's a standard case that we have done before. Probability of having the first success before the 10 throws, x less than 10. What do we do with this now? We have this formula, probability of x greater than r, that's given by q raised to power r. It's converted to that form. We have to do 1 minus something, right? Because that's greater than, this is less than. So what do we subtract from 1? You could write down some numbers to understand this better. 8, 9, 10, 11, 12, and so on. What are the numbers that you want? Less than 10. These are the numbers that you want. Right? You want numbers less than 10. What you don't want is all of these numbers. you want to get rid of these. Subtract from 1 these numbers. How would you describe them in greater than form? You would say these are numbers that are greater than 9. So 1 minus probability of x greater than 9, which is 1 minus q raised to power 9. Input values in this 1 minus 5 over 6 raised to power 9, and that should give you the result. Okay, what's this number? 1 minus 5 over 6 raised to power 9. That's 0.806. Okay, that's the probability that we get. Okay, we'll do just one more question after this, but let me respond to this question from one of you. You're saying probability that x is between 4 and 7. Is it related to the second part? Or it's just some random question? That's not from 4 to, okay, that's from 4 to 7, okay. So we're saying x being between 4 and 7, is it the same thing as? Yes, so probability of x less than or equal to 7. It's correct that this is 1 minus probability of x greater than 7. Okay, so this is correct. So maybe you can ask verbally. That will speed up things a little. We want to do one more question.
Yes, sir. So then probability of x greater than equal to 4 is equal to probability of x greater than 3. So then the total thing is probability of x greater than 3 plus 1 minus probability of x greater than 7.
Okay, I'm sorry, I got distracted a bit. Can you please repeat that?
Sorry, sir. So the question was probability of x is between from 4 and 7. So we can write it as probability of x greater than, probability of x greater than equal to 4, which means that probability of x greater than 3. So that part we can write as probability of x greater than 3. And for probability of x less than equal to 7, we can write it as 1 minus probability of x greater than 7.
Okay. Yes.
And then we add the two of them.
We can't add both of them. There isn't an or between them. There's an and between them. Both of these conditions have to be met at the same time.
Okay, sir.
So
Okay.
when you do greater than 3, that basically includes all of these numbers, 5, 4, 5, 6, 7, 8, 9, all the way up to infinity. You're finding the probability for all of these numbers. And when you do less than or equal to 7, you're finding the probability for 1, 2, 3, 4, 5, 6, 7.
Okay, sir.
That actually become more than 1, right?
We are finding the intersection. Thank you, sir.
Yes, you're finding the intersection. Okay. Okay, let's do one last question and then we end for today. And that is this one question that I have lined up for today. Yeah, question number 3. Let's do this one last question and then we end. Okay, in a certain region, the probability that any given day in October is wet it means it rains on that day. That is 0.16 independently of other days. Find the probability that in a 10-day period, fewer than 3 days will be wet. What distribution is this? Is it any distribution? This is binomial, right? We're talking about fewer than three successes. So we're talking about number of successes. We're not talking about first success. So it's about number of successes. The probability on any given day is 0.16 independently of the other days. That means the probabilities also remain constant. They do not change. So the conditions are also met. There are two outcomes. The probabilities are not changing, and we have something repeating. And we know the total number of times it's repeating. That's 10. So it's a binomial distribution in the first part, for which n is equal to 10. Probability of success, we're calling the day being wet a success. Right, this is a success. So that's 0.16. And the failure would be 0.84. What's the probability that fewer than 3 days will have rain? Fewer than 3 successes. That's x less than 3. That's the probability that we're looking for. Since it's binomial, let's write down the binomial formula. The binomial formula looks like this. NCR p raised to power r q raised to power n minus r. N is 10. So 10c, or let's actually break it down because we have an equal to formula. This is an inequality sign. Let's write it down first of all. Less than 3 means it could be x equal to 0. It could be x equals 1. Or it could be x equals 2. We have these three possibilities. Let's apply the binomial formula on each one of them one by one. N is 10, so it becomes 10c0 into 0.16 raised to power 0 into 0.84 raised to power 10 minus 0, which is 10, plus 10c1 into 0.16 raised to power 1 into 0.84 raised to power 10 minus 1, which is 9, plus 10c2 into 0.16 raised to power 2 into 0.84 raised to power 8. And that should give you the result. You can see what this turns out to be. Okay, could somebody please do this calculation? Let me know what it is. I'll move on to the next part in the meantime. So the first part was fairly straightforward. As long as you realize it's a binomial distribution, you just have to apply the formula thrice, and that gives you the result. Okay, now part B says, find the probability that the first wet day in October is 8th October. What distribution are we talking about now? We're talking about first success. Probability that the first success comes on the 8th attempt, on 8th October, you get the first success. That's a geometric distribution, right? We're talking about the first success. So now it's a geometric distribution in the second part. We have the same values of P and Q. Probability that the first success comes on the 8th day. So what we're looking for is probability of x equals 8, right? The formula for a geometric distribution is q raised to power r minus 1 times p. What's q? Q is 0.84 raised to power 8 minus 1, which is 7 times p, which is 0.16, and that should give you the result. Okay, again, a fairly straightforward second part. We get the result from this. What do we get from this? 0.84 raised to power 7 times 0.16. That's 0.0472. For the first part, you're saying it is 0.794. Okay, thank you. Okay, the second part was geometric. The first part was binomial. That's all that we had to do here. Okay, now do we assume that the 10-day period starts from 1st October? How do we know that? What are they saying? Look at the second part. So you are saying, how do we know that we are starting from 1st October, right? That's the question. Part B basically tells you that. It says probability that the first wet day in October. So they're saying in October, the first wet day should be 8th October. So we're talking about the whole month of October, right? So it has to start from first. Okay. Yes, Ibrahim?
Assalamualaikum, sir.
Walaikum assalam.
Sir, like specific questions में तो हम infinity से वो होते हैं ना, infinity से bound होते हैं. इसके अंदर like अब October तो 30 days बाद end हो जाएगा, तो how would that function?
Yeah, so that's a good question. In a proper geometric distribution, in a standard geometric distribution, the number of times you're repeating something, it's basically infinite, right? So when we do 1 minus something, then that is important that the total number, it should be infinite. Okay, otherwise it would not make sense to have the total probability as 1. The total probability for a geometric distribution is only 1 if you're talking about infinite repetitions. But in this case, it's a good point. We could not have used the inequality formula. That is why we don't have any part here which requires us to use that inequality formula. There's no problem using this formula because that's how you would do it logically as well, right? Because if you want that the first wet day in October is 8th October, then that means the first 7 days are not wet. What are the probabilities for that? 0.84 into 0.84 into 0.847 times, and then into 0.16. So if you do it without geometric distribution as well, that's how you do it, right? So this works. But the inequality formula, in this case, would not have worked because of the total number being fixed. Okay, so it's not a standard geometric. But in these problems, they would not ask you something like that in which you have to make an inequality. The equation formula still works. Okay, now the rest of you don't understand what we are talking about. It's all right. You won't run into the trouble that Ibrahim is basically talking about. Yes, Ibrahim.
अगर पूछा जाए तो वो फिर हम उसको इस तरह लेंगे ना कि 30 अक्टूबर तक एंड हो रहा है, so we will take the intersection 8 से 30 तक.
You would have to find each probability separately in that case. You would not use the inequality formula in that case. Okay, because a standard geometric distribution, it basically assumes that the total number is infinite. It's not fixed. If it is fixed, then the inequality formula is going to cause problems. So you would not use that. But it won't happen in your exam, so don't worry about that. Okay, let's look at the last part of this. It says, for 4 randomly chosen years, find the probability that in exactly one of these years, the first wet day in October is 8th October. Okay, now what does that mean? First wet day in October is 8th October. Haven't we talked about this before already? In the second part, we found the probability for this case, and that turned out to be 0.0472. Is that an exact number? 0.0472? I think I calculated myself. Okay, now it's not an exact number, so I should write down a few more decimal places because we have to use this in the next part. And then I can round it off. This is 0.0472. Okay. We already know the probability for this. And then they're saying, for 4 randomly chosen years, find the probability that in exactly one of these years, the first wet day in October is 8th October. We're talking about 4 years, and we want the probability that one of those years satisfies this condition. If we call this a success, if we call this condition a success, so a year is successful if in that year, the first wet day in October is 8th October. Okay, that year is successful. Out of 4 years, what is the probability that we have success in exactly 1 year? What type of distribution is that? That is binomial distribution. We're talking about probability of having a certain number of successes, probability of having one success. right? So that's a binomial distribution. 4 years, right? So it's a binomial distribution. Out of 4 years, we want to find the probability of having exactly one success. So it's a binomial distribution with n equal to 4, and we are looking for the probability of having exactly one success. What about the probability of success and failure? This is the criteria for success. The first birthday in October is 8th October. So this is a binomial distribution, and for finding the probability of success of this binomial distribution, we have to use a geometric distribution. We already did that in the second part. If they wanted to make this more complicated, which they can, they could combine the second and third part. So they could just completely omit the second part. Okay, so let's say the second part was not there. Then for the third part, you would have first had to do the second part, right? You would have first had to find this probability using geometric distribution, and then you would use that as the probability of success for this binomial distribution. So this is that case in which you have a binomial distribution, and inside that you have a geometric distribution, right? So the probability of success of that binomial is coming from geometric. In this case, they made it easier, that they made you find this probability in one part, and then you just have to use that in the other part. But if they had not made you find this probability in the previous part, you would have to do this working and this thinking yourself in this part as well. You will see something similar happening in normal distribution later on as well. You would have a binomial distribution. To find the probability of success for that, you would have to use normal distribution. So this happens a lot in past papers. When you do more practice, you'll get more of such questions. So probability of success is this. What about probability of failure? Let's subtract this from 1. That's 0.95278. Let's say 79. That's the probability of failure. We're talking about binomial distribution. The formula for that is NCR, P raised to power R, Q raised to power N minus R. N is 4, and then R is 1. 4C1 into P, which is 0.047214 raised to power 1 into 0.95279 raised to power 4 minus 1, which is 3. And that should give you the result. You can see what that is. What do we get from this? What's the answer from this? Okay, please do this calculation while I answer this question. Okay, that's most. Okay, so the question is, can you have conditional probability here as well? The example that you've given, that I'm not sure if that makes a lot of sense, because if it rains for the first 10 days, then the first day that it rains cannot be 8th, right? If it's raining for the first 10 days, then how can the first day be 8th? Or maybe you want to say that if it rains at least once in the first 10 days, then what's the probability that the first rainy day is 8th October? Yes. So there's nothing that you can exclude. It is possible. They can combine anything with anything. That is possible, right? Anything is possible. As long as you've done that concept, it's fair game. They can ask about that. It is possible. But you won't find many questions in this that they combine binomial, geometric, and conditional, all of them together in the same question. It's very unlikely, but still possible. Okay, what's the result that we get from this? Has anyone done this? No, you're too tired. 4C1 is 4, and then 0.047214 times 0.95279 raised to the power 3, and that gives you the result. That's 0.163. That's the probability that I'm getting from this. Okay. Can somebody confirm this? Is that all right? I'll do that myself. If I input this correctly, 0.047. Okay, it looks okay. 0.163, that's the final answer that we've got. That's it. That completes geometric distribution as well. Now, tomorrow we start normal distribution. Okay, we'll start the concepts of normal distribution tomorrow. We will try to cover at least up to inverse normal, as in we'll do simple normal and then inverse normal. I will try that we're able to do that, so that over the weekend then you can attempt questions, and then when we come back on Monday we can do some practice, and then on Wednesday we do binomial to normal approximation as well. And it looks like we might need one extra session. So next week we might need 4 sessions. So what we'll do is we will do that on a Saturday or a Friday for representation of data. So we've had one session on representation of data in which we've actually covered majority of the concepts. It's just linear transformation that is left, and the diagrams. We will have to spend one class on completing those concepts, and then one class on practice and representation of data. So 2 classes in representation of data and 3 classes in normal distribution. So we need 5 more classes. 1 is tomorrow. So next week we might need 4 classes. But let's see, we will do Monday, Wednesday, and Thursday, and then we might have to do Saturday or Sunday as well, one of those days. Okay, any questions, any problems, anyone, before we end? No? All right, I'll see you again on Saturday then, right? Later tonight. Love us.